Hello students, my name is Satyajit Pal and let us start this class for today. Okay, so today we are going to study about some programs, okay, some example programs on C++. So the first program that we will study about is Armstrong number, okay. So what is an Armstrong number? Let me explain it in a very brief manner. Armstrong number is such a number. Suppose let's say I take a number 153, okay. Suppose I take a number 153. Now if I do the sum of the cube of these digits, that means 1 plus 1 cube plus 5 cube plus 3 cube. So this will give you 1 plus 125 plus 27, right? This is 27. So you will get 153, right? So this number, if this number is equal to the original number, means the cube of these digits, if it is equal to the original number 153, then it is a Armstrong number, or else it is not. For example, let's say I do 27, okay. So if you cube the digits, 2 cube will be 8, plus if I do 7 cube, 7 into 7 into 7, so that will not give you 27, obviously, right? That will not give you 27, so that means 27 is not an Armstrong number. Now let us check one more number. For example, let's say 371. So if I do 3 cube plus 7 cube plus 1 cube, so it will again give you 371. It will again give you 371. Now this 371 is equal to this original number, right? So these kind of numbers are known as Armstrong numbers, okay. These kind of numbers are known as Armstrong number. Now let us go to the code. Now here I have four variables: num, original number, remainder, and result. Now result is initialized to 0. Okay. Now let us go and understand this code. There are four variables here. Okay. Num, original number, you have remainder, and you have result. So these are the four variables that we have, right? These are the four variables. Now these are the four variables that we have, okay. So I'm making the boxes so that it will be easier for you to calculate, okay. It will be easier for you to calculate. Now as you can see in the code, result is initialized to 0. That means I will put a 0 here first. It is already 0, okay. Now look at the code. Enter a 3-digit number, okay. Let's say the user is being asked to enter a number. For example, he enters a number 153, okay. So according to this code, what I will do at first, I will make this original number equal to num. That means it means that this 153 will get copied to this original number variable, okay. So this number gets copied here. Now why I am copying here, you will understand it all throughout the program, okay. So now this is the while loop on which this Armstrong number will work, okay. So while loop, this is the body of this while loop, okay. Now let us understand these parts one by one. Now this while loop will work till this condition is true. That means till the original number is not equal to 0, this loop will work, right? So at the first step, original number equal to original number mod of 10. So before understanding this, I want you all to know that mod, this modulus operator, checks the remainder. Okay, so suppose let's say I do 153 mod of 10. So as you know from general mathematics, the remainder is 3, right? So this mod operator calculates the remainder. Okay, that means this piece of code, remainder equal to original number mod of 10. So here what did you do after this calculation? Means original number, remainder equal to original number mod of 10. What was the original number? The original number was 153. This number, right? So original number mod of 10 will give you 3. Now this 3 gets carried over to this remainder. That means r equal to 3. Okay, r equal to 3. Now going to the second line, result equal to result plus equal to remainder into remainder into remainder. Now let me generalize this statement. This is result equal to remainder into remainder into remainder plus the original, the result. Okay, now from this calculation what do we have? Remainder equal to 3. Okay, as you can see on the screens, the current value of remainder is 3. Okay, so what will be the calculation? 3 into 3 into 3. This is the calculation, right? 3 into 3 into 3 plus what was the original value of result? The result was originally initialized to 0. The result was originally initialized to 0. So what will you put here? 0. So the end result of this is 27. I hope this is clear. I hope this is clear, right? So the end result is 27. Okay. Now this 27 gets carried over here. Means this 0 gets updated to this 0 gets updated to 27. Okay. Now let us do this calculation once again. Now going to the next step, original number divided by equal to 10. This means original number equal to original number divided by 10. Okay. Now let me generalize this statement. Original number, it is given divide equal to. Okay, divide equal to it is given. As you can see, divide equal to. This means the original number is equal to original number divided by 10. That means 153 is the current value of original number divided by 10. This will give you 15. Mod gave you the remainder. This will give you the question part. Okay, this will give you the question part. Now original number is 15. That means from the original number 3 got deducted, right? From the original number this time 3 got deducted. So the current value of original number is 15. Okay, now again going back to this code, 15 is still not equal to 0. That means the loop will run once again, right? So again in the second time, what will you get as the, see, this time 15 is just left. Okay, just concentrate on your screens. This time 3 has been deducted and 15 is only left. This 15 is left, right? This 15 is left. Now 15 mod of 10, what will you get? This time 15 mod of 10 will give you just 5. 15 mod of 10 will give you 5 as the remainder. So if you calculate, if we try to calculate this part once again, if we just try to calculate this part, this calculation once again, what will you get as the result? See, this time this will give you, see, the remainder was 5. That means this 3 will get cancelled and the updated value, this 3 will get cancelled and the updated value of here remainder is 5. That means this time the calculation will give you 5 into 5 into 5 plus the result. What is the original value of result? The original value of result is 27. Okay, so this will give you 152, right? That means this 27 will get cancelled and this will be updated to 152. Okay, this will give you 152. Now what is the next step? The next step is original number divide equal to 10. That means this time if we do simple division divided by 10, what will you get? The quotient will be just 1. The quotient will be just 1. That means what? This time this 5 also got cancelled from the original number, right? If the quotient is 1, the 5 got cancelled, right? That means the original number is still having 1. So again this time the loop will run, as because it is still not equal to 0. Now remainder equal to original number divided by 10, mod of 10, sorry. Now if we do original number mod of 10, see this time the original number is just carrying how much? 1, right? The original number is just carrying the value 1. So if I do 1 mod of 10, again the remainder will be 1 mod of 10, the remainder will be 1, right? That means this remainder value gets updated to 1, right? That means this time in the next step, result equal to remainder into remainder into remainder plus result, right? This time what will you get as the result? Let us do the calculation. Guys, just remember this current value of result is 152, okay? The current value is 152. So this time this calculation will give you, see what is the remainder? The remainder is 1. So 1 into 1 into 1 plus what was the result value? The result value is 152. The result value is 152. So this gives you 153. Okay, this gives you 153. Now coming back to the next step, original number divided by equal to 10. That means if I again repeat the procedure, this time the original number 1 will get cancelled and there will be nothing but 0 here. Okay, 1 will get cancelled and there will be nothing but 0 here. Now if we go to the while loop again, this time this statement becomes false. Okay, now once this statement becomes false, it gets out of this while loop and goes to this line. So here it is written result equal to num. Now that means it will check if result equal to num. So what is result? The result is the updated value is 153, right? This value. The updated value of result is 153. Now is it equal to this original number? If it is equal to this original number, that means it is an Armstrong number, or else it is not an Armstrong number. Okay, so this is how an Armstrong number works. Okay, so I hope this is clear to you all. Now let us go to the second program. Let us go to the next program. Okay. Now factorial. Now first of all, let us understand what is a factorial. Factorial means the decrement of the number just multiplied with itself. Okay. So 5 factorial. This means 5 into 4 into 3 into 2 into 1. That means 5 into 4 is 20, 20 into 3, 60, 60 into 2. This will give you 120. Okay. So 5 factorial means 120. So I hope you have understood what is factorial. Now let us see. Suppose let's say I do 4 factorial. 4 factorial will be 4 into 3 into 2 into 1. Okay. So what is the factorial result? 4 into 3, 12. 12 to the 24. Okay. So this is what is known as factorial. Okay. So this is known as factorial. Now let us check the program. Okay. So here I have two variables. One is n and other is factorial set to 1. Okay. Now see why it is set to 1, because at the last, so there is a rule in mathematics, if you know, 0 factorial 1. Okay. So there are two variables here. One is n. It will hold the number for which you are finding out the factorial, and the second one is factorial equal to 1. That means there is another variable known as factorial equal to, this has been set to 1. Okay, factorial has been set to 1. Now let us go through the code. The enter a positive integer c in n. That means the value which you will enter, that will get entered here. Suppose I want to have the factorial of the number, let's say 5. Okay. Now let us see how this works. N has the value 5, just remember, okay, and the factorial is having the value 1. Now when you check if n less than 0, see, if it is less than 0, suppose the user enters -5, so you don't have the factorial of a negative number. Okay, so this is by rule that we cannot take out the factorial of a negative number. This is a rule. Okay, so that is why it is being written in the code that if n is less than 0, it will give you a statement that error, factorial of a negative number doesn't exist. Okay, now coming to the else part, let us check this. Okay, so this is using a for loop, and I had explained for loop earlier. So int I equal to 1. So the iteration here, the iteration will start from I having a value 1 for I equal to 1. Now in the condition it is given I less than equal to n. Now we'll check i's value is 1. 1 is less than the value of n, 5. Is it true or false? It is true. 1 less than 5 is true. Okay, so the control goes down. It will do factorial into I into equal to I. That means it will do factorial equal to factorial into I. this process goes on repeating. Okay, so factorial value was 1 and the I value is 1, so this time it will give you 1. Now this 1 gets stored in this factorial. Okay, so originally what do you get? 1. Okay, now just mind it that after this step this goes to plus I. Okay, plus I, that means the current value of I gets changed to 2. The current value of I is 2. Now again it will check the condition I less than equal to n. That means is 2 less than equal to 5. Is 2 less than equal to 5? This is, sorry, this is again true. So again you do the calculation. What is the original value of factorial? This time 1, and the updated value of I is 2. That means fact equal to fact into I. Okay, fact equal to fact into I. That means the current value will be 1 into the current value of I, which is 2. So 1 into 2 will give you 2. Okay, so the current value of this gets updated to 2. Okay, now again going to the code, again it will check if I, it will do I plus plus, it will again get updated to 3. It will get updated to 3. Okay, now again it will check is 3 less than or equal to 5. It is still true. This thing is still true. Okay, now in the next step what happens? Again factorial equal to factorial into I. Okay, that means again what it will do, it will do factorial equal to factorial into I. That means the original value of factorial was 2, and this time the original value of factorial was 2, and this time this will get multiplied with the current value of I, that is 3, which will give you 6. Okay, this will give you 6. That means this has been updated to 6. Okay, this has been updated to 6. Now again going to the code, again it will do the updation of I. This time it becomes 4. Now again check 4 less than or equal to 5. Is it still true or not? This is still true. That means the loop will run once again, and this time what it will do, it will give you the calculation fact. Now fact was having 6, so 6 into 4, what does it become? It becomes 24. This becomes 24, and just going to this updation once again, what do you get? The corresponding value of I gets updated to 5. Now as you can see, 5 less than or equal to 5, yes or no? So this statement still is true. Be very careful with this part. 5 less than equal to 5, it is still true. That means the loop will run one more time, and this will give you 24 into the current value of I. The current value of I is 5, so it will give 5, which will give you the result 120. Okay, so the current value of this got updated to 24, and lastly it got updated to 120. This got updated to 120. Now as you can see on your screens, is this 120? Is this 120 equivalent to this? Yes, true. That means this is how the factorial is calculated. And lastly, what will you do? See out the factorial of this number is factorial. Means we'll be just displaying the value which is there in this variable. That means if we do 5 factorial, it will give you 120. Now let us run the code and see whether it works or not. Enter a positive number. Let's say I enter 6. Okay, so entering 6 we got 720. Entering 6 we got 720. That means the factorial of this is 720. 720 is the factorial value of 6. Okay, now let us run the Armstrong number once again and let's check whether this works or not. Now if we run the enter a 3-digit number, as you can see, if I try type 153, so it is displaying that yes, this is an Armstrong number. This is an Armstrong number. This is true. Now let us check with some other number whether it works perfectly or not. Suppose let's say I enter 145. So 145 is not an Armstrong number, as because 1 cube, 4 cube plus 5 cube will not give you 145. Okay. Now let us check with the other example that I gave, 371. Yes, this is an Armstrong number, as because 3 plus 7 cube, 3 cube plus 7 cube plus 1 cube will give you the original number, that is 371. Okay, so I hope these two programs are clear, and we shall be going into the next code in the next series of videos. Okay, so I hope these programs are clear to you all. Thank you very much.